Hi, welcome you back to my another video. In this video, I'm going to talk about multiplexer, 4x1 multiplexer. So let me show you the picture for this 4x1 multiplexer. So this is the picture with the truth table, logic diagram and expression. So if you see here in the truth table, S1 as S0 both are selection line. Y is the output, and here we can see the inputs I0, I1, I2 and I3. So these possible combination numbers are made possible because of this condition. So n is the number of selection line, so 2 to the power n. Okay, so let's say n is 2, n is equal to 2, and then we have 2 to the power 2 is equal to 4. So 4 possible combinations and then 2 selection line, hence 4 inputs and then 2 selection line as mentioned. Basically the output will be selected based on the selection line. Okay, it depends upon the selection line. So whenever selection is 0 0, I0 will be selected and I0 will be given into the output I0. And then similarly, if 1 1, if selection is 1 1, then I3 will be selected and then I3 will be given into the output. Okay, so here we have expression for this 4x1 multiplexer, and then I have written here in the reverse order. Okay, so here like I3 and then S0 and then S1. Okay, so why I have mentioned here S1, S0, I3, because for S1 the input is, the value is 1, so there is no bar. Okay, and similarly for S0 it is 1, so there is no bar or negation, you can say like that. Or S1, S0 bar and I2. If you go up here, S1 is value is 1, so just keep it as it is, S1. And then if you see here in S0 it is 0, that means bar. Okay, I've mentioned here bar or negation or inverter, you can say any one of them, and then followed by S1 bar, S0 and I1, because in S1 if you see here the value is 0, that's why it's mentioned as a bar. Whereas if you see here S0 is 1, so there is no bar, and similarly I1. And lastly we have S1, S0, so both are having 0, hence S1 bar, S0 bar, and then followed by the input I0. Okay, now moving to the logic connection out here. S1, S0 is the selection line, and then the output will depend upon the selection line. So here in this line, or you can say in this terminal, these are all values of 1. And then if we have, like here we have NOT gate, right? The NOT gate, when we know the operation of NOT gate, whenever you give 0, then it will be given as 1. Whenever you give 1 as input, then 0 will be in the output. So this entire terminal is the value of zeros. Similarly, this terminal is considered as 1 value, and then this value is considered as 0 value. Now you can see here there is 4 AND gate, because here we can see the min terms, right? They are AND with OR, right? AND. Okay, so these all AND gates will be combined together in one OR gate. So multiplexer means multiple inputs and only one outputs. So we can see here there is multiple inputs, but in the output we are getting only one output. So based on this expression we have designed these logic gates. Now if you see here I0, let's go from here. I0 is the input, followed by S0 bar and S1 bar, right? You see the truth table, S1 bar, S0 bar, and then I0. These are the inputs. So you can see here I0, S1 bar, okay, that's 0 value, and then similarly S0 also having a 0 value. So we have chosen this terminal. Okay, now If you go next, I1 S0 S1 bar. So I1 S0 and S1 bar. So if you see here in these logic gates terminal connections, you see here I1 is given as it is, and then S0 is 1, so we have taken in the 1 terminal of S0, and then S1 is 0, so we are taking here in this line. Okay, now if we go to the next one, let's go to the last one. Let's consider this one, S1 S0 I3. So these are all 1 values, right? S1 is the value is 1, even the S0 is 1, and then we are getting I3 also, I3 as input. So I3 is input, and then S1 is 1, and then S0 is also 1. So they are all into the AND gate as input, and then providing the output as W4, W3, W2, and W1. So we can see here, like for this gate, okay, this is NOT gate. Why we are using NOT gate? Because for selection S1 we have 1 as well as zeros, so this terminal will be 1 as I've told you, and then after this NOT gate this terminal will be 0. In order to get 0 input, we need to make this one. Okay, so this will be providing 0 value, this will be providing 1 value. Similarly for this S0, 1 value and 0. So I have mentioned here as P1 for the S1 and then P0 for the S0. To make it meaningful, W1, W2, W3, and W4. That means wire 1, wire 2, wire 3, or wire 4. Okay, so this entire wire will be again or with the output, and then we are going to get the output as Y. Okay, according to this expression. I'm going to follow this logic diagram. So by following this logic diagram, it will be more helpful. Okay, let's begin with the module max 4x1, and then we have to mention the input terminals, right? The port list. So I0, I1, I2, I3, and then we also have S1, S0, Y. Now we have to declare the input output ports. Input I0, I1, I2, I3, and then S1, S0. We have output Y. So I'm going to use gate level modeling, since this is the gate level, already it's in gate level, so I'm going to just code this one out here. Let's begin with this NOT gate. Okay, so mention NOT gate, these are primitive. Okay, these are all primitive. NOT gate is predefined. NOT gate, we have 4 AND gates, right? So I'm going to mention here AND gate, and then we have one more OR gate, so I'm going to mention it OR. Okay, so mention as gate 1, and then gate 2, gate 3, so with that gate 4, gate 5, gate 6, and then gate 7. Okay, and let's go and then write down the arguments. So for this NOT gate, let's consider this is NOT gate G1. First of all, we have to write down the output followed by the inputs. So P0 is the output for this NOT gate, so we have to write down here P0, comma, and followed by input. So input is S0, S0. Similarly for the next one, P1 is the output, S1 is the input. So write down P1 is output, S1 is the input. Next we have AND gate, right? So I naught is the input, P naught is the input, and then P1 is the input, right? So write down those things. So the first of all we have to write down the output, right? So W1, so W1 is the output followed by the input. So I naught and then P naught, P1. Next we have to write down the same thing for this W2. So W2 comma, and then what are the inputs? I1, and then we have S naught, okay, S naught followed by the P1. Next we have W3. So in W3 what are inputs? I2, and then we have S naught, right? No, it's S, instead of S naught it should be P naught, right? P naught, it's in P naught terminal, so P naught and then followed by the S1. And next we have W4, and what are the inputs? I3 followed by the S naught and then S1, right? So S naught and S1. So lastly, what we have in OR gate, all these output of AND gates are combined into the OR gate, and then we are getting only one output. So W1, W2, and then W3, W4. So these are the design code for this 4x1 multiplexer. Let me enlarge this windows. Now if you see here, we have completed the design. Okay, design part is over. Now let us go and write down the test bench. Now we have to write down reg I naught, I1, I2, I3, and then followed by S1, S naught, and then wire is I. So why we are doing this? Because we want to give a stimulus, right? We want to provide a input. So let's concatenate the inputs, but before that let us instantiate. Okay, I forgot to do that. We have to instantiate the design. We have to bring this design into the test bench. So we have to write down the name of the module as mux, whatever is mentioned out here we have to write down the same thing. Okay, mux 4x1 design under this is the name of the instantiation, and then within the bracket we have to write down these ports. So I naught, I1, I2, I2, I3. So you have to follow the same pattern. So this one is an instantiation by position. Okay, now let's include the inputs, and then followed by S1 and S0. So dollar random, make sure that you give a delay. Since we are given a 5 transaction, if we didn't give delay, then it will be executing at 0 time. So make sure that you give 1 nanosecond so that the transaction will have 5 nanosecond, and then you have to give dollar monitor for viewing the output and inputs. So I naught, A1, so this is the code for the test bench. I hope it's clear to you now. Now let us select the simulator tools and then let us run this code to check the functionality of the 4x1 multiplexer. So let's run this code. Now we are getting Y as Z. That means it's impedance, right? Why we are getting this? Let's find it out. So we are not getting output, it's mentioned as high impedance because we forgot to give here the output, right? We forgot to mention here output, so make sure that you give Y. Okay, we forgot that. So let's run again. Okay, now we are getting the output, right? So if it is 0 0, then it will select I naught. So what is the value of I naught? 1, right? So in the output we are getting 1. So next we have 0 1, that means it will select I1. So what is the value of I1? It's 0, we are getting 0. Next we have another I1, okay, that means 0 1, that means it's going to select I1, right? So it's going to get 0, so output is 0. Next we have selection is 1 1, that means it will select I3. So you see the value of I3, it's 0, hence the output also 0. And similarly we have another 0 1, that means it's going to select I1. So I1 value is 0, hence the output is 0. So I hope you guys have understood this 4x1 multiplexer. So see you in the next video. Thank you.